Now the first question is, if the coordinates of a variable point be p, t plus 1 by t, t minus 1 by t, sorry, it will be t plus 1 by t, t plus 1 by t, t minus 1 by t, where t is the variable quantity, then the locus of point P is. So the point is given, coordinates are given in terms of t, so the locus is to be what? As I have discussed in the previous video how to find the locus, there are some steps. Step 1 is you have to take point P, the point which locus you have to get, take it as ph comma k. Step 2 is derive equations, derive relevant equations. Step 3 is solve to eliminate other terms than h and k in one equation. Solve to eliminate other terms than h, k in one equation. And in the step 4, in the final and the last step, just substitute x, h with x and k with y. Then you will get your required locus. Okay, so this is the general steps which you have to follow in all kinds of sums which are related to the finding of locus of a point. So now let's come to the solution. As I said in step 1, take point ph comma k, and it's given that h is equal to t plus 1 by t and k is t minus 1 by t. So in the next step, let's take h is equal to t plus 1 by t. It's actually given, I am not taking, it's given. K is equal to t minus 1 by t. We have just assumed it as h and k. So now squaring both sides, we get h square equal to t square plus 1 by t square plus 2. And in this side, k square equal to t square plus 1 by t square minus 2. So now let's take these two equations as equation number 1 and equation number 2. Now let's subtracting 2 from equation 1. Subtracting equation 2 from equation 1, we get that h square minus k square h square minus k square is equal to t square plus 1 by t square plus 2 minus t square minus 1 by t square plus 2. Okay, so from here, by cancelling t square and 1 by t square, we get h square minus k square is equal to 4. Now this is the equation where we have already eliminated the term t and we have kept only the relevant terms of h and k in my final equation. Since I have eliminated them, now I am taking h as x and k as y, and I have got the locus as x square minus y square is equal to 4. Okay, so this is what p was given as t plus 1 by t and t minus 1 by t. I have taken p as h comma k, derived equations, eliminated the irrelevant term which is t and irrelevant parameter which is t, and then got the final equation in terms of h and k, and then substituted h and k with x and y to get the final locus of the point P, which is option number C, x square minus y square is equal to 4. Okay, so this is actually important question. Such types of questions come repeatedly in WBJEE, and you have to practice more questions of this type. And let's go on to the next question. Okay, the next question is, the locus of point P which divides the line joining 1, 0. The locus of point P which divides the line joining 1, 0 and 2 cos theta, 2 sin theta internally in ratio, internally, mark this word, internally in ratio 2:3 for all theta, is what? They have said whether the locus of the point will represent straight line, circle, parabola or whatever. Okay, so use locus steps as I have discussed in the previous sum. Now let's take point P as h comma k, and in the section formula we used to take the divisions as m is to n. So here it's given as 2:3. M is to n is equal to 2:3. So now let's take the points which are given. Let's take the points which are given as x1 comma y1, which is equivalent to 1 comma 0, and x2 comma y2, which is equal to 2 cos theta. x2 comma y2 is equal to 2 cos theta comma 2 sin theta. Okay, so these are the points which the line joining a and b, x2 comma y2 and x1 comma y1 internally. So we have to get the point locus of the point which is dividing internally, cutting this line segment in ratio 2:3. So now let's take h as mx2 plus nx1 by m plus n. Now putting the relevant values, we are getting this form, and for similarly for k, my2 plus ny1 by m plus n. So by this we are getting that h is equal to 4 cos theta plus 3. Okay, here m is 2 and n is 3. So now from this we are getting h is equal to 4 cos theta plus 3 by 5. I guess I haven't done something wrong here. It's 4 cos theta plus 3 by 5. So h is equal to 4 cos theta plus 3 by 5. From here you have to get the value of cos, which is 5h minus 3 by 4. Similarly, sin theta is equal to 5k by 4. Now from trigonometric identities we know that from basic class 7 knowledge we know that sin square theta plus cos square theta is equal to 1. So therefore, from substituting the values of cos theta and sin theta to eliminate the terms theta, we have got this as 25k square by 16 plus 5h minus 3 by 4 whole square is equal to 1. By solving these equations, we have got this form in the type of 25h square plus 25k square minus 30h, 25h square minus plus 25k square minus 30h minus 7 is equal to 0. So in this type of equations of coordinate geometry, whenever at any place you will find the coefficient of h square and k square, or coefficient of x square and y square equal, then just get sure that it is a circle. Okay, by the way, in the last step you have to take h as x and k as y. Okay, this is important. So option B is the correct answer. The locus of the point P will be a circle, since coefficient of x square and coefficient of y square is equal to 0. There is no xy term in this equation, for which we don't have to check whether it's a parabola, ellipse or a hyperbola. Okay, since no xy term and h square k square has similar components, it will be a circle. Now coming to the next question. The sides of a triangle are in length 3x plus 4y, 4x plus 3y and 5x plus 5y units. These are the lengths given in units. Okay, this is the length where x greater than 0 and y is greater than 0. The triangle is right angle, acute angle, obtuse angle or whatever. So for solving this question, let me first draw a triangle with sides AB, BC and CA, and let's take BC has units 3x plus 4y, AC has units 4x plus 3y and AB has units 5x plus 5y. Now, since many students will face some doubt in this question, before starting the question I want to mention here that the given values in terms of x and y, 3x plus 4y, 4x plus 3y, these are not the equations of sides of the triangle. These are not the equations of sides of the triangle, rather these are lengths given in terms of x and y. don't confuse yourself whether the given x and y are the coordinates or the it's somewhere related to the coordinate axis. It's not. X and y here is just used to denote the lengths and units. Okay, so let's take a is equal to, a means the length of the side BC, 3x plus 4y, and length of the side AC as B, which is 4x plus 3y, and length of the side AB as C, 5x plus 5y. Now for checking, there is a step, there is some trick. First of all, you have to check whether it's a right angle triangle, because WBJEE board is repeatedly, or by analytically, I have saw that they are interested in right angle triangles very much. So for checking whether it's a right angle triangle, check Pythagoras theorem, which states that c square is equal to a square plus b square, where c is the hypotenuse and a and b are the two sides which are at 90 degree. We have assumed here that it's a right angle triangle. Now check whether our assumptions are correct or wrong. So a square plus b square will be what? 9x square plus 16y square, and so on, by expanding the given values, by expanding the given expressions. Finally, we will get it as 25x square plus 25y square. Okay, so this is actually a square plus b square. Okay, we had assumed c square equal to a square plus b square. Now a square plus b square is equal to coming as 25x square plus 25y square plus 48xy. Now coming to expanding the formula for c square, it's coming as 25x square plus 25y square plus 50xy. So it's greater, c square is greater than a square plus b square by a term of 2xy. A square plus b square, there was everything same except it was 48xy, and c square, there is everything same except it is 50xy. So c square is greater than a square plus b square, means the hypotenuse, value of the hypotenuse is not matching. The value of the hypotenuse is somewhere greater than the required value of the hypotenuse. So you already know that it's the case of an obtuse angle triangle. So option C will be the correct answer. Okay, so hope it's clear. It's an important question. Again, it's an important question. You will have to solve this type of questions. This is important. Now let's move on to the next question. It's given as, if the coordinates of the centroid and the vertex of an equilateral triangle are 1, 1 and 1, 2 respectively, then the coordinates of another vertex are, means the coordinates of the other two vertex will be what if centroid and any one of the three vertex of the equilateral triangle are given. How will you find the other two vertices? So we denote centroid of any triangle as G, which is the summation of x coordinates by 3 and summation of y coordinates by 3. Now let me draw the coordinate axis and draw the point which is the centroid as 1, 1. Here is the origin O. Let's take the point 1, 1. Suppose let it be here 1, 1, and then the given vertices, the given vertex, let it be A, which is 1, 2, and let me join this. Now to be precise, we know that in any type of triangle, we know specifically for equilateral triangle or any triangle, we know that centroid of the triangle, I am writing here, the centroid of the triangle lies at 2/3 distance. Sorry, not 2:1. It's we can write it as, to be clear, we can write it as 2/3. 2/3 distance from vertex centroid of triangle lies at 2/3 distance from vertex towards the base. So distance base, so base, the distance of the centroid from the base will be, the distance from base will be 1/3. The distance of centroid from base will be 1/3 of the total distance between the top vertex and the base. Now let me extend the point G to the base and denote it as D, which the coordinate of D will be 1, half. 1, half. Why I have taken it as half? Because the distance between point A and the centroid is 1. So therefore it will be much half less to make it in 2/3 distance and 1/3 distance in 2:1 ratio. And let's take the side length of the triangle as A. All three sides have equal lengths. So point D has coordinates 1, half. Now from this triangle ADC, consider the Pythagoras theorem. It will be a square equal to a by 2 square plus h square, where h is the length of AD. So by solving we will get that h is equal to root 3a by 2. Now root 3a by 2. So now let's take it, root 3a by 2 is equal to 3 by 2. What is 3 by 2? That is the distance AD. Distance AD. The ordinate of A is 2 and ordinate of D is half. So by subtracting half from 2, it's 3 by 2, which is the required length of AD. So now root 3a by 2 is equal to 3 by 2, and from here we can get the side length of the equilateral triangle as root 3. Now if it's root 3, then we know that the straight line joining from the upper vertex to the base of the equilateral triangle is the median line. So therefore, if it is the median line, then we can say as BD is equal to DC is equal to root 3 by 2. So from here, by concepts of geometry and coordinate calculations, you can get the required coordinates of the required vertices of the triangle, where coordinates of C will be 1 plus root 3 by 2 half, and coordinates of point B will be root 3 by 2 minus 1 half. Okay, so this is a very important question. It's a conceptual question, but a very easy question actually. So get grip of such type of questions and try to approach them like this graphically and by the help of diagrams. Okay, you don't even have to write so many things. Just drawing the figure perfectly will do your job. Now let's come on to the next question. It's said that point 3, minus 4 and point minus 6, 5 are extremities of a diagonal of a parallelogram, and minus 2, 1 is its third vertex. Then its fourth vertex is what? Its point to be noted here is that the extremities of a diagonal of a parallelogram. Then what will be the fourth vertex if the given coordinates of extremities of diagonals are given of one diagonal and the third vertex is given? So let me first draw the diagram. These are the extremities of a diagonal. Let's say the bigger diagonal, and let me draw the smaller diagonal. And let me take the meeting point as O of the diagonal, where they are the two diagonals are intersecting, and the third vertex, let's take it as minus 2, 1 in the rightmost side top corner. We know that diagonals of a parallelogram bisect each other and at the midpoints. By the midpoints means the diagonals have a midpoint. The line diagonal is a line segment which has a midpoint, and that midpoint is the point of intersection of the two diagonals in a parallelogram. So to be precise, we can state this statement as diagonals of a parallelogram bisect each other and at the midpoints. So what will be the midpoint here? So the coordinates of the point O, here O will be the midpoint, so coordinates of O will be -6 plus 3 by 2 comma 5 minus 4 by 2. So it will come as O is minus coordinates of O are -3 by 2 comma half. So now let's again come back to equating it with h comma k. Let's take this point as h comma k, the unknown vertex. So -3 by 2, the x coordinate of the point O is equal to h minus 2 by 2. It's the midpoint of this smaller diagonal. -3 by 2 is equal to h minus 2 by 2, and half is equal to k plus 1 by 2. So from here we can solve for h and k, and gradually we will get the unknown vertex. Therefore h comma k is equal to -1 comma 0. Option A is the correct answer. So this is again an important question. Such type of questions do practice. Now try to get hold of this, and this statement is important. This is the statement which you have already learned from the junior classes, and that is really going to help you a lot. So thank you. I have finished with the first chapter of coordinate geometry, that's Cartesian coordinates, and now let's move on to the chapter of straight lines from the next video. Best of luck.